Well, dear students, in our last class, we started with a new chapter, that is structure of atom. I said that atom is derived from the Greek word atomio, which means that indivisible, which carries subatomic particles like protons, neutrons and electrons. And the discovery of protons, neutrons and electrons we have studied. And how these protons, neutrons, electrons are distributed around the atom. Atom ಅಲ್ಲಿ ಅದರ ಲೊಕೇಶನ್ ಹೇಗೆ, ಎಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ, protons ಎಲ್ಲಿರುತ್ತೆ, neutrons ಎಲ್ಲಿರುತ್ತೆ, right? That is given by means of the model, Thomson atomic model and Rutherford atomic model, right? According to the Thomson atomic model, atom is spherical in the shape and positive charge is uniformly distributed and electrons are enclosed within it, right? So this is according to the Thomson atomic model. But according to the Rutherford atomic model, what most of the space inside the atom is empty. This positive charge is located at the center, and this center is called as what? Nucleus. And electrons are revolving around the positively charged nucleus in a random movement. Okay. So once the Thomson atomic model and the Rutherford atomic model has been published, later Niels Bohr, he formulated, he just changed, he considered some of the drawback of the Rutherford model, because Rutherford model has got many of the limitations. According to the Rutherford model, the structure, the stability of electron is not explained by the Rutherford model, as well as how these electrons are distributed around the nucleus. The distribution of electrons, stability of the electrons and stability of the atom is not explained by Rutherford model. So he used that limitation, and our limitations use ಮಾಡಿಕೊಂಡು he just modified the model. That modified model is called as Bohr model of the atom. But before publishing the Bohr model of atom, he considered the limitations of Rutherford model. Okay, if you look at the Bohr here the positive charge is it is there at the center according to the Rutherford model, and electrons are revolving around it. Okay, like how sun is at the center and it is surrounded by the planet, here also positive charge is at the center and it is surrounded by the electrons. But according to the classical mechanics, okay, according to the classical mechanics, classical mechanics means it is the study which deals with the motion of the object, the movement of the object in the influence of a force. Object ಮೇಲೆ force exert ಆಗುವಾಗ how it is influenced by the movement of the object ಏನಾಗ್ತದೆ, when the force is acting on the object. What about the movement of object? Okay, that is usually called as classical mechanics, which deals with the motion of object with the influence of what? Force. It may be the centrifugal force, it may be the centrifugal force or the gravitational force. Okay, right. So any object, so if you consider this Rutherford model, according to the Rutherford model, okay, when the electron is revolving around the positively charged nucleus, what happens? Electron with the positive charged nucleus is positive, electron negative, what happens? There is attraction. So that electrons has got the more force towards the positively charged nucleus. So when this accelerated electron attracting towards the nucleus, positively charged nucleus, what happens? The electron will lose its energy. Correct? The electron positive charged nucleus around and move ಆಗುವಾಗ ಈ ರೀತಿ electron consider ಮಾಡಿದ್ರೆ, when this electron is attracted more towards the positively charged nucleus because of the positive force, it will be attracted towards the positively charged nucleus with the loss of energy. Energy will be liberated. Yes, once the energy of electron lost, we can say that electron is collapsing towards the positively charged nucleus. And the electrons, once it lost the energy, it is not stable at all. That electron will charge nucleus ಇರಬೇಕು ಸರೌಂಡಿಂಗ್ ಟು ಇಟ್. ಬಟ್ ಇನ್ ದ ನೇಚರ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಸೊ ಹ್ಯಾಪನಿಂಗ್. ಅರ್ಥ ಆಯ್ತಾ? ಏನು ಈ ಇಲೆಕ್ಟ್ರಾನ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಮೇಲೆ ಕೊಲಾಪ್ಸ್ ಆಗಿರುವುದಿಲ್ಲ. So that the energy of the electron and the stability of the atom is not explained by what Rutherford model. So he used that limitation and he said that Bohr model, he said that Bohr said that yeah, positive charge is there at the center, but that electron doesn't have in the random motion. That electrons are moving in the particular path, and that particular path he called it as what? Shell, or he called it as what? Stationary state. Stationary state. When the electrons are moving in a stationary state or in the orbit, the energy of the electron and the radius of the electron, it is usually fixed. Change ಆಗುವುದಿಲ್ಲ. ಯಾವಾಗ changes ಆಗ್ತದೆ ಅಂದ್ರೆ when that electron undergoes excitation, when that electron undergoing excitation, all that electrons is coming to the ground state, only then the energy or radius of the electron get changed. Okay, according to the Bohr model of the atom, he said that electrons doesn't having the what random movement, it is having the allowed orbit. In the allowed orbit only electrons movement can be observed, and the energy of the electron and the radius of the electron, it is fixed, doesn't change with the time. But here the Rutherford, if you consider the Rutherford model, what happens? The energy of the electron is reduces, as well as it doesn't give any information about the radius of the electron. Okay, and the distribution of electron also not explained. So he formulated the Bohr formulated the model, and he proposed the Bohr model of atom. But before proposing the Bohr model of atom, there are some inventions were going on, that is dual behavior of radiation and atomic spectra. So James Maxwell ಏನು ರೇಡಿಯೇಷನ್ ಇದು ಡ್ಯುಯಲ್ ಬಿಹೇವಿಯರ್ ಬಗ್ಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾನೆ. ಸೊ he consider the dual behavior of radiation. ರೇಡಿಯೇಷನ್ ಇದು ಕೆಲವೊಂದು ಬಿಹೇವಿಯರ್ಸ್ he used in explaining the structure of atom and molecule. So some of the features of the dual behavior of the radiation gives immense information towards the structure of atom. So what are the inventions before giving the Bohr model of the atom? There were some inventions that will be what gives more information to propose the Bohr model of the hydrogen atom. That is dual behavior of the radiation and the atomic spectrum. Dual behavior of radiation and atomic spectrum. Atomic spectrum. Remember students, okay, before proposing the Bohr model of the atom, ಒಂದು limitation of Rutherford model ಅಲ್ಲಿ ಗೊತ್ತಿರಬೇಕು, ಇನ್ನೊಂದು ಏನು dual behavior of radiation ಮತ್ತು atomic spectra ಇದರ ಬಗ್ಗೆ ಇನ್ಫಾರ್ಮೇಷನ್ ಗೊತ್ತಿರಬೇಕು. ಯಾಕಂದ್ರೆ ಇದರಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿ ಆದ ನಂತರ in detail ಆಗಿ you will be having what you will be having more information. You will be in the position to understand what is the Bohr model of the atom. That is why called as a development leading to the Bohr model of atom. Direct Bohr model of atom ಅನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡೋದಲ್ಲ, ಈ Bohr model of atom ಅನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡೋ ಮೊದಲು what are the developments before proposing the model. Okay, so dual behavior of the matter, so dual behavior of the radiation. Radiation, it is usually having the dual character. ಎರಡು character ಇರುತ್ತೆ. ಒಂದು radiation has got the wave nature, ಇನ್ನೊಂದು radiation has got the particle nature. ಒಂದು ಪಾರ್ಟಿಕಲ್ ನೇಚರ್ ಇದೆ ರೇಡಿಯೇಷನ್ ಗೆ, ಇನ್ನೊಂದು ಏನು ವೇವ್ ನೇಚರ್ ಇದೆ. ಈ ಪಾರ್ಟಿಕಲ್ ನೇಚರ್ ಇರುವ ಕಾರಣ ರೇಡಿಯೇಷನ್ ಇಟ್ ಈಸ್ ಶೋಸ್ ದ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಫೆಕ್ಟ್ and also which shows for the black body radiation, and also which shows the variation of heat. In detail agi what is photoelectric effect, black body radiation, variation of heat on a solid as well as a spectrum. Okay, light magnetic radiation. Innೊಂದು along with the wave nature, light also having the particle nature. Particle nature ಅಂದ್ರೆ light also carries what atoms. So that atoms will be having the photoelectric effect. That will be shows the black body radiation. That will be shows the variation of heat capacity on the solid and the spectra. That is light spectra, emission spectra, and absorption spectra. Okay. Alright. So that will be considered real behavior of the radiation. ಇನ್ನೊಂದು atomic spectra. ಪ್ರತಿಯೊಂದು atom, like how fingerprints of each and individual, it is different. Each and every atom will be produced as the spectra. Okay, so digitally ನಾವು ಸ್ಪೆಕ್ಟ್ರಾ ನೋಡಿಕೊಂಡು ನಾವು ಒಂದು ಸ್ಪೆಕ್ಟ್ರಾನ ಸ್ಟಡಿ ಮಾಡಿದ್ರೆ ಸರಿ ಯಾವ ಆಟಮ್ ಇದೆ ಸ್ಪೆಕ್ಟ್ರಾ ಅಂತೀವಿ. ಆ ಸ್ಪೆಕ್ಟ್ರಾ ನೋಡಿಕೊಂಡು therefore this is a particular atom ಅಂತ ನಾವು ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡ್ತೇವೆ. Like how fingerprint of the each and every person, it is different. Atomic spectra of each and every atom is also different. So therefore here in the atomic spectra we are going to study about the emission spectra and absorption spectra, and in that line spectra also comes. Real behavior of matter alli photoelectric effect, black body radiation, variation of heat and the spectra, and here the wave nature of the radiation. So here we will study step by step. First, dual behavior of the nature, in that wave nature of the light. Okay. First one, dual behavior alli ಒಂದು wave nature, ಇನ್ನೊಂದು particle nature. So we will study the wave nature of the radiation. Okay. So how the waves will be produced? Waves ಅಂದ್ರೆ ನೀವು ನೇಚರ್ ಅಲ್ಲಿ ನೋಡಿರಬಹುದು. ಒಂದು ಸ್ಟೋನ್ ಅನ್ನು ವಾಟರ್ ಗೆ ಹಾಕಿದಾಗ ಏನು ವಾಟರ್ ಅಲ್ಲಿ it will be produced as the wave. ಅದೇ ರೀತಿ if you consider the light, if this is the direction of propagation, it is the direction, light is the direction ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, see, it will be you can observe light is having the wave nature. A wave nature ಯಾಕೆ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತದೆ ಅಂದ್ರೆ it is because of the alternating electric field and the magnetic field. It is due to the alternating electric field and the magnetic field. If you go through it, ಯಾಕೆ waves produce ಆಗ್ತದೆ ಅಂದ್ರೆ if I rotate the pen or if I use the rope ಅನ್ನು ಯೂಸ್ ಮಾಡಿ ಈ ರೀತಿ ಮೂವ್ ಮಾಡಿದಾಗ any object in the movement, ಯಾವುದಾದ್ರೂ ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನು ಮೂವ್ ಮಾಡುವಾಗ it will be produces what? Wave. Okay, it may be the sound wave, it may be the light wave. Because sound waves are spatially, when the waves are where the light or the sound which is moved through the space, what happens, it is usually produces the waves. A waves yaake produce agtadre in the what direction? In the direction of propagation, it produces the alternating electric field and the magnetic field. ಇದು electric field agide, it produces the alternating what? Magnetic field. ಈ electric field ಗೆ perpendicular ಆಗಿ magnetic field produce ಆಗುವ ಕಾರಣ radiations ಗೆ ಇದು wave natures ಬರುತ್ತೆ. Okay, so because of that wave nature, what are the some of the fundamental properties involved? What are the some of the fundamental properties used to measure the what? Radiation. Some of the fundamental properties of wave. How can we define the wave? Wave ಅನ್ನು electro ಹೇಗೆ define ಮಾಡಬಹುದು? You know that light waves propagate through the space by producing the alternating electric field and the magnetic field. So radiation called as what? Electromagnetic radiation. Because of the electric field and the magnetic field, the light has got the wave nature. Remember, light has got what? Wave nature. So since the wave has got both electric and magnetic field, it is usually called as what? Electromagnetic radiation. ಅರ್ಥಾಯ್ತಾ? ಯಾಕೆ ವೇವ್ ಅನ್ನು electromagnetic radiation ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡೋದು? It is because the light waves propagate through the space by producing alternating electric field and magnetic field. Therefore, it is called as what? Electromagnetic radiation. So, what are some of the properties, fundamental properties of the wave? Okay. See, in general, simple ಆಗಿ ನಾವು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡುವಾಗ ಇದು ಡೈರೆಕ್ಷನ್ ಆಫ್ ಲೈಟ್ ಅಂತ ಆಗಿದ್ರೆ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಈ ರೀತಿ ನಾವು ವೇವ್ಸ್ ಅನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾರೆ. ಕರೆಕ್ಟಾ? ಸೊ ಹಿಯರ್ this is usually called as what? Crest, and this is usually called as what? Truth. So some of the fundamental terms used in the measurement of a waves. The first measuring term used, it is wavelength. Okay? Wavelength can be given by the symbol lambda. Okay? And it is usually having the unit. Wavelength is measured in terms of a meter. Remember? And how can we define the wavelength? Wavelength can be defined as it is the distance between the two successive crests and the successive truths. The distance between the successive crest and truth is called as what? Wavelength. What is the wavelength? Distance between the successive crest and the truth is called as what? Wavelength. It can be given in terms of meter, that is usually in nanometer, and it is given by the symbol lambda. Okay? And the second term used is frequency. Frequency, it is usually given by the symbol mu. Okay? Mu, lambda, mu. And its unit is hertz. Okay? Or in the capital letter H Z. Or it is also given in terms of per second. Okay? How can you define the frequency? Frequency can be defined as ಈಗ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಇಂದ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಒಂದು ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಹೌ ಮೆನಿ ಟೈಮ್ಸ್ ಲೈಟ್ ವೇವ್ಸ್ ಪಾಸ್ ಆಗುತ್ತೆ, ದಟ್ ಇಸ್ ಯೂಶುವಲಿ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಫ್ರೀಕ್ವೆನ್ಸಿ. ನಂಬರ್ ಆಫ್ ಲೈಟ್ ವೇವ್ಸ್ passing through the point per second is called as what? Frequency. What is the wavelength? It is the distance between the two successive crests and the truth is called as what? Wavelength. Frequency means it is number of light waves passing through a point in second, per second. Okay, number of waves passing through a point per second is called as what? Frequency of the radiation, the frequency of the wave, and it is usually measured in terms of hertz or per second. And third measuring term, it is speed of wavelength, speed of light. That is wavelength velocity. Velocity, it is usually given by the symbol c. Remember, symbol c. This value of velocity per second, it is 3 into 10 to the power 8 meter per second. So how to remember the velocity? Speed of light. And light, it is a speed of light per second. It is usually given by what? Velocity. Velocity and define ಮಾಡೋದು. It is the speed of light per second is called as velocity. Frequency ಅಂದ್ರೆ ಇದು number of light waves passing through a point per second. Distance between the successive crests and truth is called as wavelength. and velocity is given in meter per second, and its value is 3 into 10 to the power 8. And the last fundamental term property it is used in the measuring electromagnetic radiation, it is wave number. Wave number. Okay. All these properties, all these terms you have studied in your high school level itself. Just we glance what are the definitions of it. Okay. Wave number is usually given by mu bar. Remember, it is usually given by mu the variable, other line the mu bar. And wave number, it is equal to the reciprocal of wavelength. Remember, reciprocal of wavelength is called as what wave number, and it is usually measured in terms of a meter per meter. Remember all those points: wavelength, other unit; frequency, other unit; velocity, other unit; as well as wave number, other unit. Then, what is the relationship between all the fundamental factors? What is the relationship between all the fundamental factors? The relationship between the speed of light, velocity, wavelength, frequency, and wave number is C is equal to mu lambda. Remember this formula? C is equal to mu lambda. Related to that formula, you will be having the many 1 mark or 2 mark questions. Okay, problems out there. C is equal to mu lambda. What is the relationship between the velocity, frequency, and wavelength of electromagnetic radiation? Right. So here you can also write this equation as mu is equal to C by lambda, or we know that 1 by lambda is equal to what? It is mu bar. Or you can also write this equation as mu is equal to C mu bar. First formula, second formula. What is the relationship between the different fundamental factors? That is, C is equal to mu lambda as a main formula. Then mu frequency can be given as C by lambda, or frequency is equal to C mu bar, because 1 by lambda it is equal to what? 1 by lambda is equal to what? It is equal to mu bar. Okay? Right here. And also remember the point, next class ಅಲ್ಲಿ ನಿಮಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡುವಾಗ ಈ ಟರ್ಮ್ ಬರ್ತದೆ. ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ದ ರೇಡಿಯೇಷನ್ ಇನ್ಕ್ರೀಸ್ ಆಗೋದಂದ್ರೆ ಏನು, wavelength of the radiation ಕಮ್ಮಿ ಆಗೋದು ಅಂತ ಅರ್ಥ. Okay, as the wavelength increases, frequency decreases, ಅಥವಾ as the frequency increases, wavelength of the radiation is usually what? Decreases. Okay, and related to this formula, we'll be having some numerical problems that we'll discuss in our next class. Okay, and before that, let me complete the concept. There will be radiation and wave nature of light. These radiations are arranged based on the increasing value of their frequency or wavelength. It is usually called as what? Electromagnetic spectrum. In the nature, we are having the different types of radiations. Yaudella radiations we already ಗೊತ್ತಿದೆ. X-ray, gamma ray ಗೊತ್ತಿದೆ. ಅದು ಬಿಟ್ಟು ಬೇರೆ ಯಾವ್ದು radiations ಗೊತ್ತಿದೆ? Of course, radio waves. Broadcasting ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೇವೆ, radio waves ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೇವೆ. And then it is microwaves. ಕೆಲವರು ಮೈಕ್ರೋವೇವ್ ಓವನ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಹೀಟಿಂಗ್ ಪರ್ಪಸ್ ಅಲ್ಲಿ ಮೈಕ್ರೋವೇವ್ಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತಾರೆ. And then infrared rays, IR, it is usually used in the purification, in killing of germs, IR. Okay, infrared radiation. Visible, because of the visible rays, we can see the object anna we can clearly see because of the visible region. Then ultraviolet rays, UV rays, since in the cancer therapy ಆಗಿರಬಹುದು, ಕರೆನ್ಸಿ ಫೇಕ್ ಕರೆನ್ಸಿ ಕನ್ವರ್ಟ್ ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ. And X-rays and gamma rays. So that different arrangement of the radiation, different radiations, we know that different radiations are arranged based on their frequency or their wavelength, which is usually called as what? Electromagnetic spectrum. What is electromagnetic spectrum? Arrangement of the radiation, electromagnetic radiations, in the increasing order of their frequency or wavelength called as what? Electromagnetic spectrum. Electromagnetic spectrum. Electromagnetic spectrum. What are the different electromagnetic radiations comes under the electromagnetic spectrum? That is long radio waves, second one is a microwave, third one is a infrared, or it is also called as an IR. Fourth one is visible rays. Fifth one is the UV rays or ultraviolet. And sixth one is X-ray. Seventh one is a gamma. When you study some of the radioactive reactions, this gamma rays were used. X-rays were used to find out the breaking in the bones. Okay, X-rays are used. Ultraviolet rays, it is usually used in killing the germs. Visible rays, it is usually used to see the object. Infrared rays, it is used in heating purpose. Microwaves, it is usually used in the radar system to detect the object detect radar system is used as well as it is used in the oven also. Long radio waves broadcasting is used you must know the range, frequency range. Long radio waves have got the 10 to the power 6 Hz frequency range. Microwaves 10 to the power 10 Hz. The infrared waves 10 to the power 13 Hz. The visible is 10 to the power 15 Hz. Ultraviolet is 10 to the power 16 Hz. X-rays 10 to the power 18 Hz. Around it, approximate around so long radio waves are 10 to the power 1 in the 10 to the power 6 okay. Gamma rays are more than that. Okay. Just range in case entrance level adra ಬಗ್ಗೆ ಕೇಳಿದ್ರೆ ಈಗ 10 to the power 15 Hz range usually ಯಾವ waves ಬರುತ್ತೆ, that is visible rays. So like that, different rays. Arrangement of the different electromagnetic radiations based on their frequency or wavelength is called as what electromagnetic spectrum. Okay. Yes, we discussed in detail about the particle nature in our next class. So this is what the wave nature of the light. You can say that ಇದರಿಂದ ಬೋರ್ ಮಾಡೆಲ್ ಆಫ್ ಆಟಮ್ ಅಲ್ಲಿ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಹೇಗೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಬಿಕಾಸ್ ಇಲ್ಲಿ ಹೇಗೆ ರೇಡಿಯೇಷನ್ ಅಲ್ಲಿ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದ ವೇವ್ ನೇಚರ್. ಲೈಟ್ ಹೇಗೆ ಮೂವ್ ಆಗುವಾಗ ವೇವ್ಸ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ಅದೇ ರೀತಿ when the electrons are moving around the nucleus, it also produces the waves. Okay, so therefore wave into property study ಮಾಡಬೇಕಂದ್ರೆ ಇದೆಲ್ಲ ಕ್ಯಾರೆಕ್ಟರ್ಸ್ ಇದೆಲ್ಲ ಫಾರ್ಮುಲಾಸ್ ಗೊತ್ತಿರಬೇಕು ನಿಮಗೆ. So therefore Niels Bohr, before proposing the Bohr model of atom, he has considered the concept of real behavior of radiation and the atomic spectra. ಇದೆಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು finally he has given the Bohr model of atom. Okay, remember students that formula. So we discussed some numerical questions related to that formula in our next